Hello, hello. Thank you guys for coming to this YouTube channel and watching these notes about functions and domain and range. This is going to get you ready for the calculus class. So here we go. A function is a relationship that pairs elements from x from the domain with a unique element y from the range. Okay? So in order to tell you what a function is, sometimes it's best to tell you what a function is not. Okay, so here's a good illustration of a function. This would be like the square root function. Okay, that's a good function. This, however, may be the graph of a sideways parabola, is not a function. And the reason it's not a function is because if I were to plug in one x value, I would actually get two different y values. I would get, let's say, 1 and 5 at the same time. Okay, so a function is one-to-one if every element in the domain is paired with exactly one element in the range. All right, well, let's talk about functions again. So here's a function. If I have one x value and it goes to, let's say, a y value. Okay, so let's make a picture of this one. Function, let's say the 1 goes to a y value of 1, and then x3 also goes to a y value of 1. And then let's say x3, let's say, I don't know, let's say that one's equal to 2. So this was 1, 3, you know what, let's put it in order. 3 and then like 5. Okay, so 5. And let's say that its output was something like 3, okay? So our output for both of those was 1, so it might look like this, might curve. And then at 5, the output is 3, so 3, okay? So this one is a function, but it's not a one-to-one function. And so basically one-to-oneness, it would have to pass something called the horizontal line test, okay? So in calculus, we're going to be pretty interested in one-to-one functions. This is not a function at all, so this is one of those cases where you have a sideways parabola maybe, or maybe it's the graph of a circle. Okay, and the graph of a circle is not a function because it fails the vertical line test. One of these x values goes to two different y values. All right, actually all of them do, right? For a circle. So one-to-one functions, they're just going to be super nice. They're going to pass both tests. I could say pass both tests. And what tests am I talking about? The vertical and horizontal line tests. Okay, so those are the functions that we're going to mostly be dealing with, and thankfully, right, we're excited to have nice, smooth curves in a lot of calculus. So I shouldn't have called them nice, smooth curves, but nice one-to-one functions, I guess. Okay, so when you're talking about domain, there are a few inputs that are just illegal given the function. So if you have something like x squared, if you're familiar with the function and the way it looks, its domain is going to be all real numbers. So basically it just means that I can plug in any x value I want and I will always get some kind of y value. However, once you start using fractions like this and you have x value in the denominator, you should know that that denominator, that x value there, cannot be 2. So this is going to be all real numbers except for positive 2. So you can say x is not equal to 2, or you could say all real numbers except x equals 2. All right. And if you looked at the graph on that one, then you would see some kind of vertical asymptote more than likely at x equals 2. Okay, so here's the square root function, and I told you that the square root function is a function that we'll be using a lot. So this is a square root x, but this one is square root x minus 5, so that one needs to be moved over to the right 5. And if we move it to the right 5, it'll still look like a bottle rocket. So what are the allowable numbers? Well, the domain then, that pen's a little dark, it's almost the same color as that black. So the domain is going to be all these numbers to the right of 5, and also including 5. So we're just going to say that x can be greater than or equal to positive 5. Another way to do that problem is just to set the x minus 5, make sure that it is greater than or equal to 0, because the inside of a radical needs to be greater than or equal to 0. Just like this, the denominator cannot equal 0, so you could solve that inequality as well. All right, so now let's look at this bottom one, and this is something to attack early in the calculus curriculum because it's not mentioned much. But if I had x squared minus 9 and I set it greater than or equal to 0, then well, I think adding 9 is okay, and that's appropriate, but it's taking the square root that gives people the headache. All right, me too, right? Okay, if I were to take the square root of something squared, it actually, if we were doing this, x squared equals 9, most people just say x equals plus or minus 3. And your teachers weren't wrong for telling you that, but they're kind of skipping a step. This step is of absolute importance all of a sudden. Taking the square root of something squared actually gives you the absolute value of x. And now that I have the absolute value of x, the only way to get rid of that is actually just to assume that the inside is positive, or assume that the inside is negative. All right. I'm not sure if I explained that very well. So let's see. X is greater than or equal to 9. And then what else could I have said? I could have said this. Negative x is greater than or equal to 9. I would have had to divide both sides and got x, flip this sign, less than or equal to negative 9. So if the inside's positive or negative, if the inside's positive, that would be fine. If the inside was negative, it would actually be written as negative x is greater than or equal to 9. And then you'd have to divide both sides by negative, and that changes this sign. So anyways, the domain this time, the domain is going to look at negative 9, all these numbers, and at positive 9, all these numbers to the right. So x is less than or equal to negative 9, or x is greater than or equal to 9. So I encourage you now to pause the video and go to your TI-84 and look at these graphs. If you do not have a TI-84, I do encourage you to go over to Desmos and type these in and just look at the domain. Make sure that it makes sense to you. Domain, all real numbers. I can plug in any x value. Let's go to the domain for the second graph. All right, or look at the second graph and be convinced that x cannot be 2. It looks like x cannot be 2, right? So push trace 2 and see what you get. You get a blank right there. That's a tall tale sign that it isn't equal to. All right, the domain cannot equal 2. All right, let's look at the square root of x minus 5. It's that bottle rocket that I promised you. Push trace 5. You do get a value at 5, so it is greater than or equal to 5. We'll go back over to y4. Hit graph. And look at this. That's a pretty cool looking graph, right? So we're going to hit trace, -9. Oh, wait a second. I messed up! Oh! Well, I'm not going back to change the video. I don't know how to do it. So anyways, I hope that you guys caught that. When you take the square root of both sides, you get 3. I showed you that over here, right? So anyways, all of these numbers are 3. So, shame on me. All right. So that is, if you have technology and you can put it in, it might be best to just check it. So anyway, -3, I'm getting the value 0. So that means that the function is defined at -3, and it's also defined at 3. So that's why we have this little equal sign underneath. And I tell you what, I'm going to save the next part of these notes for a separate video because this one's getting a little long, and because I want you to be able to focus on just those important functions in the next video. All right, hope you enjoyed. Later.